Okay, so this is part 2 of the difference of two squares. And in this part, um, the difference of two squares, it's a little bit more complicated, but not really. And you can see what I'm talking about. But let's kind of review the difference of two squares. So basically, if you have a binomial, and the sign between the two terms is subtraction, and the two terms being raised to a second power, or being squared, then this can be factored as a minus b times a plus b. And notice that this right here, this expression right here, is called the difference of two squares. And so the difference of two squares can be factored as a minus b times a plus b. And so we saw in the previous video that when you fall this out, the outer and the inner, they add up to be 0. And so that's why you don't have 3 terms, but you only have 2 terms. Okay? All right, so in part 2, we're going to look at this kind of examples. Suppose you want to factor. And remember, anytime you see the word factor, it's factor completely. So let's suppose you want to factor m to the 4th minus 1. All right, so m to the 4th minus 1. In the previous videos, the variable was being raised to the second power, and so there was no issue. There It wasn't that difficult. This isn't difficult either, although this is not a 2. The exponent is not a 2. But whenever you have two terms, first of all, let's make sure we understand that whenever you're factoring a polynomial, you want to factor out the GCF if it's other than 1. So in this case, the GCF of these two terms is 1. So then, since I have two terms and there's a subtraction sign between them, then I want to see if this is the difference of two squares. So checking to see all I'm doing here, this little step, now that's not the answer, but that's a step you can use to determine if this is the difference of two squares. So checking to see if this is the difference of two squares. If the binomial is the difference of two squares. All right, so basically you want to see, can I put something in these two parentheses? So this one's easy right here, because what times itself twice is 1? Well, obviously 1. So 1 goes here. Over here, what times itself twice, what times itself twice, let me redo this, what times itself twice is m to the 4th, right here. What times itself twice is m to the 4th? Well, m squared. M squared times m squared times m squared. Remember, you multiply like bases, you add exponents, is m to the 4th. So m to the squared goes inside this first set of parentheses. So this is the difference of two squares. And so we factor it as a minus b times a plus b. So in other words, m squared minus 1. So m squared minus 1 times m squared plus 1. Okay, and keep in mind also, it doesn't matter whether you put, and we talked about this in the last video, whether you put a plus b times a minus b or a minus b times a plus b, because multiplication is commutative. The order in which you multiply does not matter. Same thing applies here. You could have written it as m squared plus 1 times m squared minus 1. Okay, all right, now see this right here? So you want to see if each of these two binomials can be factored further. So you always check. Don't always assume that you're done. You got to check your polynomials, your factors within this answer that you think this is. All right. So m squared minus 1. Remember, that's called the sum of two squares. So the sum of two squares. This right here. The sum of two squares cannot be factored. All right. So you can't factor the sum of two squares. All right, so that was in a previous video. So the sum of two squares cannot be factored. All right, so this right here is the sum of two squares. Now right here, m squared minus 1, that is the difference of two squares also. So right here, That is the difference of two squares. So m goes inside the first parentheses because m times m is m squared. And then over here, 1 goes here. So I can factor m squared minus 1 as m minus 1 times m plus 1. And so that right here goes here. So I get m minus 1 times m plus 1 times this, which is the sum of two squares, which we know we cannot factor. And so you're done. That is the answer to that example. Okay? All right, let's look at this one. Suppose we had, let's see. All right. All right, suppose we had x to the 6 minus 81x squared. So x to the 6 minus 81x squared. Okay, so just as before, you want to look for a GCF. So the GCF here is x squared. The GCF is x squared. All right, so you want to factor out the GCF x squared. So I get x squared times x to the 4th, because x squared times x to the 4th is x to the 6th. When you multiply like bases, you add exponents. 2 plus 4 is 6, minus 81. So that's what I get. Okay, so now you see this right here, this x squared, x to the 4th minus 81. You want to now check and see if this, there's two terms, there's subtraction between them, so you want to see if that's the difference of two squares. So is this the difference of two squares? So if it is, let me rewrite this. So you want to see if that's the difference of two squares. So can I complete, or can I fill in these parentheses? So what times itself twice is x to the 4th? Well, it's going to be x squared, because x squared times x squared is x to the 4th. What times itself twice is 81? Well, the answer is 9. So this right here is the difference of two squares. Now again, that's not the answer. You got to go further with this. So you got to factor it. So you're going to say x squared minus 9 times x squared plus 9. Okay? Now, just like we did here, right here, you got to see if you can go further with any of these. So remember, this right here was the sum of two squares, which we know we cannot factor. But this right here was still the difference of two squared, so I can go further with it. So that's where I get this. Same thing here. So if you look at these two factors, this right here is the sum of two squares. So I cannot factor this one. But this right here, x squared minus 9, that's the difference of two squares. And so I can factor it as x minus 3 times x plus 3. And then we just rewrite this part here. So x to the 4th minus 81. X to the 4th minus 81, we saw that that's the difference of two squares. So I can factor it further into two binomials. So x squared minus 9 times x squared plus 9. And then you want to go further. You want to make sure that what you have, these factors are prime. So this one's prime, x squared plus 9. I can't factor any further, so I rewrite it. This one is the difference of two squares, so I can factor it further. Okay? Now, remember, that right here, this right here is the factorization for this, but that was not the original problem. So the answer, don't forget, has to include the GCF x squared. So the answer is x squared times x minus 3 times x plus 3 times x squared plus 9. Okay, so that's your answer. All right, so there, these are your factors: x squared, x minus 3, x plus 3, x squared plus 9. Okay. All right, let's see if we can do one more. Let me try and find an example. Let's suppose we want to factor. Okay, let's suppose we want to do this one. So this is going to be, let me do the next page. We're going to do one more with this. So 144 minus 81x squared. So 144 minus 81x squared. All right? Okay, now, again, the first thing you always want to do is look for a GCF. And the GCF here is not 1. The GCF here is 9. Because if you look at this, 144 divided by 9 is 16. Okay? So you want to take out the 9 first. So I get 9 times 16, because 9 times 16 is 144. Remember, the GCF is 9. And then minus, over here, there's going to be 9x squared. Okay? All right, so we have so far. All right, now remember, that's not the answer, because you got to look at this factor here and see if this right here, these two terms, that factor, is the difference of two squares. And you can look at this and see that it is. This right here. Because I can write 16, that's a square. I can write 16 as 4 squared, and I can write 9x squared as 3x. So this factor here, I can go further with it. That's the difference of two squares. So I'm going to get 4 minus 3x times 4 plus 3x. Okay? And so that's going to go here. So the answer is going to be 9 times 4 minus 3x times 4 plus 3x. Okay? All right, so that's your answer. Now, let's suppose the same example. Suppose you didn't factor out the GCF. All right, suppose you didn't factor out the GCF. So if you look at this, you can notice that the way it's written, that structure, 144 minus 81x squared, it is the difference of two squares itself. So in other words, 144 is 12 squared minus, and then 81x squared is 9x. Okay? So if you forgot, and you really shouldn't, but if you forgot to factor out the GCF of 9, you would have this, and then you would say, all right, so this is the difference of two squares, so I'm going to get 12 minus 9x times 12 plus 9x. Okay? But remember, just as we were doing, I'm going to go to this page here, just as we're doing, remember, you don't automatically say that's the answer. You got to look at these factors and see if you can factor them further. So look at these factors right here, and see if you can factor it further, and I could in each case. So the same thing here. What do you notice about 12 minus 9x? This one right here. Well, 12 minus 9x, I can factor out a 3 from that. So I get 3 times 4 minus 3x, because 3 times 4 is 12, and 3 times a negative 3x is a negative 9x. And the same thing here. I can factor out, remember that's multiplication, I can factor out a 3, and I get 3 times 4 plus 3x. All right? Now, don't leave your answer like this, because we expect you to know that 3, these monomial factors, 3 times 3 is 9. So you want to say 9 times 4 minus 3x times 4 plus 3x, and which is what we got here. Okay? So, in this case, if you had forgotten to factor out the GCF, you would have noticed at the end that each of those factors right here has a GCF of 3. So this factor has a GCF of 3, this factor has a GCF of 3, you factor it out, and then you get the correct answer. Okay, so that's going to end this video.